So just a couple more things to mention. First of all, what we're going to look at now is just interpolation and extrapolation of the data. So if we have our scatter diagram, and I mentioned in the last video that that would be positive correlation, that way would be negative correlation. What I didn't mention was, generally speaking, when you actually look at correlation, what you tend to get for positive correlation, and I did draw it but didn't state it, is you actually get your positive correlation ending up forming a little bit of an ellipse. Now, you don't tend to get straight line correlation like that. In the real world, you do tend to get correlation that takes a kind of elliptical shape as it goes through, and obviously negative it would be the other way around. And as the correlation gets weaker, you'll have seen me add points in here because actually it still takes an elliptical shape. Now remember, obviously your samples have to be representative of the real world, so doing a sample size of 2, for example, well, that's not big enough really. So you do have to have a sort of set size. Now generally speaking, in mathematics, about 100 would be fine, 1,000 would be better, so on and so forth. But obviously you're doing statistics 2, you're only at A-level side, and so generally speaking we'll try and keep it quite simple. The next thing that I wanted to mention as well was when you're looking at the data, a couple of points come up. Because obviously I came into school this morning, for example, and I looked at the time of day and I looked at the temperature, and I saw that as the time of day increased, well, the temperature increased in a linear profile we'll go for, so something like that. And I thought, oh, fabulous. Well, if I carry on this with a line of best fit, and we're going to talk about lines of best fit in a moment, then actually as the time increases, the temperature increases. And so what's going to happen is, for example, tomorrow, well, it's going to be scorching hot. Oh, brilliant. And herein lies the problem with what we end up doing, because actually what we've got is we've got data that ranges from this time to that time. Now if I was looking, for example, just about here, which is only just out, I could treat it a little dubiously, but I might still be able to keep that line of best fit going through. But actually, if I'm looking somewhere inside of the data where I know it definitely works, then I can use that a lot better. And so if I try and extrapolate the data, so I'm going outside of the region where I know, well, this, we all know that's just gobbledygook, because the temperature will rise and fall depending on day and night. And so be very wary of extrapolating data. Interpolating data, you're fine, but extrapolation, you're not fine. Now I'll just show you a real life example of that. So the classic example to use is the experiment they did in Key Stage 4. So here I've got a lovely little experiment, and we're looking at a spring with a pan with a load of weights in, and you start dropping the weights on the spring, and the spring extends, then you plot the graph when it returns back. You start with a weight of 1 gram, 2 grams, 3 grams, 4 grams, so on and so forth. So I'll put grams in there. Oops, wrong layer. So I'll put grams in here for the moment. And then what you get is you get an extension. So other way around, they put force and extension, it's fine. Then what happens is at one point, well, you stretch it too far and it just goes a bit pear-shaped. So what we can say for sure is definitely between here and here the relationship is linear. But if we looked a little further out, then we see actually the relationship starts not to be linear, and it reaches the limit of its elasticity or something, I think I remember. We've got the videos on the science area in additional maths Key Stage 4, look at Hooke's law. So after this, for example, you have permanent deformation. And so if you get to this point here, the spring will never return back to its original length, it just stretches out. So this bit here, between that value and that value, we can say a linear interpolation, or an interpolation will give us an accurate value, but we can't then say that the relationship carries straight on, because actually it doesn't. Now you've all, regardless of whether you're at the school or not, all have done that in year 10.